Good day, everyone. Once again, we are back together, and this time we're looking at question five, based on work, energy, and power on the June 2022 exam. Okay, so if you haven't subscribed, please just make sure that you're part of the family. All right, and we say welcome to those of you who have just joined us. Okay, and we're looking to grow this family to 100,000, 200. Hey, who knows, a million. Okay, yeah. So please just make sure that you like and share. Tell as many people as you possibly can. About the work that we do here. All right, and for those of you who need assistance with mathematics or physical science, of course, you're more than welcome to always get in touch with us. Okay, we do have our classes that are running on a weekly basis. Obviously, they are paid for. In this case, you can also join us there by emailing info@mlungisinkosi.co.za. And hey, please, you're more than welcome to also give super thanks, okay, which is a monetary gift that you can give to me, all right, for the good work that I always try to do. Okay, tell your parents that hey, give Malume some some super thanks there. All right, now let's get right into it. So they say we've got arrestor beds rather are used to help moving trucks to move to a stop when their brakes fail. So they say the driver of a 30-kilogram truck driving down a steep road drives rather onto an ascending arrestor bed inclined at 28 degrees. Okay, of course, the picture tells 1,000 words. Okay, to the horizontal as shown in the diagram below. All right, now they say to us state the work energy theorem in words. Remember, the work energy theorem simply says the net work done, okay, on an object is equal to the change in kinetic energy. Okay, or you can simply say the work done by the net force is equal to the change in kinetic energy. All right, now the next part, they say the truck with failed brakes passes point A, okay, at the beginning of the arrestor bed at 33 meters per second. All right, so we know at point A we are at 33 meters per second, okay. All right, and then they say the average frictional force on the truck is 31 newtons while the truck moves up the arrestor bed. Okay, so we know there'll be friction that is acting, and by the way, that friction will be opposing the motion. Okay, as the truck goes up the arrestor bed, okay, the frictional force will be opposing the motion. Right, and then they say ignore the rotational effects of the wheels. Of course, that's important. Okay, and then they say give a reason why the net work done on the truck while moving in the arrestor bed is negative. Right, now think about it. All the forces that will be acting on the truck, just think about, well, let me not say all the forces in this case, all the forces that are parallel to the incline. Okay, so think about it. As the truck goes up, which forces will be acting on the truck? Okay, it will be the frictional force, right? But it will also be the parallel gravitational force in that case, which is always acting down the incline. So your FG parallel there, as well as your frictional force, okay, will be opposing the motion. So as a result, because they are opposing the motion, in this case, it means that the network done will be negative. Okay, right. So they say use energy principles to calculate the minimum length of the arrestor bed needed. If you don't mind, I'm just going to just move down so that we're able to do that. I hope you don't mind because I'm just going to keep toggling through our diagram. So first of all, we know that we've got a situation. In fact, let me just change the color of this thing. So we've got a situation where we are looking at the forces that are acting on the incline, right? So which forces would be acting? So we know first of all we've got we said we've got the frictional force, which would be opposing. Let's say this was our incline, which is at 30, that was 38 degrees, if I remember correctly. 28 degrees, sorry. Malume is getting old. Okay, so that is 28 degrees. Okay, so we want the length of this incline surface, which is over here. Okay, so we want that delta x there. But we also have, we said the gravitational force, okay, the parallel gravitational force, okay, but we know we'll have the normal force as well as, the perpendicular component of gravity. Okay, right, of course, those two vertical forces, perpendicular forces obviously are not contributing to the motion of the object, right? So now we're simply going to use the work energy theorem and say, well, the net work done on an object is equal to the change in kinetic energy, okay? So this is going to be the net force multiplied by delta x. Remember, this is what we're looking for, right? Multiplied by the cos of theta, and this is going to be the change in kinetic energy. Right, now let's do that. So remember, they said, what's the distance required for the truck to stop? So we know the velocity at this point should be 0, right? And what was the velocity when the truck started the ascent? It was 33 meters per second, right? So now, remember that for us to get the component FG parallel, right? I'm just simply going to, just cover that quickly. So this is going to be mg, the sine of theta. Now, in this case, please remember this theta here is the angle of elevation, right? So this is going to be the mass of the truck was, that's 30,000. Okay, so that would be 30,000 multiplied by 9.8. Remember, this is going to be, in fact, I don't have enough space there. So that's going to be 30,000, right, multiplied by 9.8. The sine of, remember, that's the angle of elevation, that's 28 degrees, right? Let me try and get my calculator there. Okay, in this case, so please just keep in mind that when you're talking about just the angle of elevation, or FG parallel, you must always make it a point that you use the angle of elevation. So we said that's 30,000. Okay, that's multiplied by 9.8. Okay, times the sine of 28 degrees. Okay, let's close that bracket there. Okay, so I get that's 138,024.64. Okay, so you know what? Maybe let me just bring my calculator over this side. Okay, so this is going to give us 138,024.64 newtons. So this is our FG parallel. Now keep in mind, in this case, we still have the force, the frictional force. So those are the two forces. So if you are going to look at the net force, sorry about this. So if you are going to look at the net force, you're looking at two forces essentially that are acting, in the same direction, which would be FG parallel, right? Or rather, you can say minus FG parallel minus the frictional force. Okay, I'm going to call it kinetic friction. So we're going to take that force there, and we're going to add the frictional force to it. Okay, so this is going to be 138,024.64 plus, in this case, in fact, I should have said minus that value, okay, plus a negative. Now remember, I'm considering the direction of motion as being positive. It always helps us there. A negative, in this case, the frictional force. Our frictional force value, I think, was 31,000, right? Correct. So that was negative 31,000 newtons. Okay, right. So if we add those two up, so that's plus 31,000. Okay. All right. So I get a force of 169,000. So that would be minus 169,000 and 24.64 newtons, right? Now, of course, you could have done that. You could have actually done that right here onto the calculation. But, I always like to work separately in this case. Now, please, I want you to note, when you now substitute that net force there, I know that we actually got that to be negative, right? But please, you are just substituting the absolute value of the force. Sorry, that's in newtons. So in this case, it means you disregard that sign, and I'm going to show you why. Okay, so that's going to be 169,000 and 24.64 multiplied by delta x. Now, this is the reason why you disregard the sign. Because now when you look at the cos of the angle, now this angle here, remember we always say this is the angle between direction of motion and the force in question. So where's the motion going? It's going upwards, right? But this net force, what is it telling us? It's telling us that the net force is going down, and that's why we got that negative value, right? Now the question is, what's the angle between the direction of motion and the direction of the force in question? And I'm sure you can see that that is 180. And by the way, ladies and gents, a cos of 180 is -1, and that compensates for that negative there. Okay, right, and this is equal to, okay, it seems like I don't have sufficient space here. Okay, I'm going to try and create some space. All right, so, yeah. Okay, so let's do this. Okay, so this is going to be change in kinetic energy. So that's going to be the half the mass of the truck. Remember, that's 30,000. Okay, multiplied by VF squared. Okay, which is 0 squared. We said our final velocity there is 0. Minus VI squared. Remember, our initial velocity was 33. Okay, squared in this case. And of course, all we're just simply going to be doing is working on our mathematical gymnastics, right? So if we can take out our calculator. I'm really not going to waste time as much with this. Okay, I'm going to say, okay, I'm going to invert the answer later on. Please, you can do it however you like. Okay, so I'm going to just simply say divide by 0.5 times 30,000. In fact, maybe I should have just, so that times 30,000. Okay, and multiplied by that 33 squared, right? Multiplied by 33 squared. Okay, right, so that's the value that I got. Okay, but remember, yeah, it seems like okay, maybe let me just start over. So that's 0.5 times 30,000. I did say, sorry, that's 15,000, right? Okay, so that's 15,000. I see this calculation is just showing me flames now. Multiplied by 33 squared. Okay, so I get that huge value there. Okay, and I'm going to now divide it. Okay, please remember, so in this case you get, I'm going to divide by this value over here. Okay, so that's divided by So that's our answer, divided by 169. Okay, let's delete that. Divided by 169, 024.64. All right. Right. So the answer that I get there, and of course, what I did was just disregard those negatives there. Either way, you'll get to the same answer. Okay. So the answer that we get is 96.64 meters. So it means that the distance there would be simply 96.64 meters. Okay, please don't worry about how I calculated it there. Remember, cos of 180 just gives you negative, so you would have had a negative value here. When you calculate on this side, you would have gotten a negative because of that minus sign there. And of course, negative divided by negative gives you a positive. Either way, we'll end up at the same answer. All right, so I hope you understood that calculation there. All right, and then the last portion, they say the diagram below shows the same truck entering a descending arrestor bed, okay, inclined at 28 degrees to the horizontal. They say the initial speed of the truck and the average frictional force are still 33 meters per second and 31,000 newtons respectively, right? Now they say which arrestor bed, ascending or descending, will be able to stop the truck in a shorter distance. Okay, they say explain your answer. Okay, so what I'm going to do here, please remember Newton's laws, right? So think about when the truck is descending. Okay, so it means you would have FG parallel acting downwards, okay, and frictional force opposing it. All right, so yes, very true. Cause somewhat of a disturbance there. Okay, it would cause the truck to stop, right? So in this case, what it does is it will cause the shorter in a longer time. Sorry about that disturbance. Right. So in this case, it would cause it to stop. Why? Because if you think about it, it would cause it in this case the net force would be lesser. But in this case, if the truck was going up, in the one that was ascending, right? You've got two forces that are acting. You've got FG parallel acting downwards. You also have frictional force acting in the same direction downwards. So your net force in this case is much greater in opposing the motion, right? Whereas only here, you've got only one force that's opposing, okay? And remember, the bigger the net force in this case, the bigger the acceleration, right? I hope I'm making sense with that explanation. Okay, let me try that again, right? So in the first instance, right, where we've got where the truck is ascending, right? We said, look, what are the net force? What are the forces that are acting? Both of them are opposing the motion. So you've got a greater net force here that's opposing, right? And when it's going down, you've got only one force opposing, which is the frictional force. So in this case, what is it going to do? It is actually going to, the net force in that case would be less, right? So remember, the bigger the net force, the greater the acceleration or the deceleration in this case. So obviously, it would take a shorter time for the for the scenario where the truck or the arrestor bed is ascending. Okay, right. So to answer that question, they said which arrestor bed? We know it's the one that is ascending. Okay, and in this case, they say explain your answer in terms of forces. We did say that the net force increases. Okay, so F net is bigger. Okay, for the ascending part. All right, so in this case, the bigger the net force, the bigger the acceleration. Okay, the bigger the acceleration in this case, or deceleration, you can say deceleration. Okay, deceleration in this case. And what it does is that it will cause the truck to stop in a shorter distance. Okay, right. Hopefully that made sense. All right. Sorry about that disturbance. These devices are connected, but of course I do hope that you understand. All right. So I will see you guys next time. Please don't forget to hit that subscribe button if you haven't already. And of course, you're welcome to give us super thanks, just a monetary gift, just to say thank you, Malume. And I will see you guys again next time. Sharp, sharp.